All right, now we're going to collect the data for the redox and single displacement experiment. So if you look at the first page of that experiment where you're supposed to start collecting the data, it should look like this. And it tells you what you're doing is you're mixing together these different solutions. So we're starting out with an aqueous solution of zinc nitrate, and we're going to add some magnesium to it. And we're going to look for any indications that a chemical reaction occurred. So we're going to take a little bit of magnesium, and we're going to add it to our silver nitrate. And I don't know if you can see that there are some bubbles being generated in there, so there's an indication that there was a chemical reaction. So you should write the word reaction there under A for magnesium plus zinc nitrate. In the next part of your experiment, you're going to add some lead to some zinc nitrate and then see if there's a reaction or no reaction. So we have our test tube with zinc nitrate, and now we're going to add some lead to that test tube, and we're going to look for any signs of a chemical reaction, and we really don't see anything going on there, so we're going to write no reaction for mixing lead with the zinc nitrate. Then we're going to move on. We have some lead 2 nitrate in this test tube, and we're going to add some copper to it and see if we get a reaction there. So we'll scoop out a little copper, add it to our lead 2 nitrate, and we'll look for any signs of a chemical reaction, and there really doesn't seem to be anything going on there. So we're going to write no reaction for C, copper plus lead 2 nitrate. Moving on, we have a silver nitrate solution, and we're going to add some copper to that. So we're going to scoop out a little copper and add it to our silver nitrate solution, which is right here. Mix those together and look for any signs of a chemical reaction. And hopefully you can see that that is bubbling vigorously. So we're going to say that we saw a chemical reaction when we mixed our copper and our silver nitrate. Moving on, we have some hydrochloric acid in this test tube. We're going to add some copper to it and see if we see any kind of reaction going on. So we're going to scoop up a little bit of copper, throw it in our hydrochloric acid, and you can see there's really nothing going on there. No reaction, so no reaction for E. We're writing that down here. Then we're going to we have another test tube with zinc chloride, and we're going to add some, with hydrochloric acid, we're going to add some zinc chloride, or some zinc to that hydrochloric acid. Sorry, hard to talk while you're trying to do this. So here, hydrochloric acid, and we added our zinc to it, and you can see it's bubbling vigorously, so we have a reaction there. Next, we're going to mix some magnesium with some hydrochloric acid, so we have another test tube of hydrochloric acid here. We're going to add some magnesium and see if we get a reaction or not. And again, we're seeing a vigorous reaction, so we would write reaction there for magnesium plus hydrochloric acid. And if you're following along, I'm going to need you to add a letter H on the bottom, where we're going to mix some lead and hydrochloric acid, and I'll show you how to put that in. But here we have hydrochloric acid, and we're going to add a little bit of lead to it and see if we get a reaction. And once again, we have a vigorous reaction. So that's an extra equation you should be writing down there as another letter. Right, and so you should be writing down H, lead plus hydrochloric acid, and that you saw a reaction with that. I will be posting this data on Canvas, so you can go back and try to record it. Now that we've collected that data. I'm going to show you what we're going to do with that data. So if you flip to the page, your next page in your lab, you should have a chart that looks like this, but it's the equations we just did. But I'll show you how to fill it in with this theoretical data here. So let's imagine that one of our experiments was adding aluminum to copper sulfate, and that we saw a reaction, and that another one was adding this copper to silver nitrate, and we saw a reaction here. And we added aluminum to hydrochloric acid, and we saw a reaction. And we added copper to hydrochloric acid, and we saw no reaction. So what we've collected so far, if you have a bunch of these equations and you have whether there was a reaction or not. If there was a reaction, that meant that the equation went forward, that something happened when we mixed this aluminum with copper sulfate. And what you're expected to do then in this lab is predict what the products of that single displacement reaction is. And in a single displacement, this aluminum is going to replace this other metal and now be with the sulfate. So we have to do several things. We have to balance the equation and we have to predict what the products are. So from our periodic table, we know that aluminum forms a +3 charge. So if we have aluminum with a 3+ charge and we look at our polyatomic ions and see that sulfate has a 2- charge, and we do our cross multiplying, we need 3 of these for every 2 of those. So one of the products is going to be Al2 with 3 of these sulfates. We should have left a spot there to balance this. And the other product is the copper now is coming out of solution and it's going to be a solid. Right. So those are our 2 products from this reaction. Then we would have to go through and balance this equation. So we have aluminum plus copper sulfate going to aluminum sulfate plus copper. So we're trying to balance our copper. We'll do our sulfates as a group and aluminum. So here we have 1 aluminum, 1 copper, and 1 sulfate. Here we have 2 aluminum, 3 sulfates, and 1 copper. So it looks like we could quickly put a 3 here, and then we would end up with 3 copper, 3 sulfate, and 1 aluminum. So we have this part balanced. We have 3 copper here now, so we need 3 copper over there. 3, 3, and 2. We have 2 aluminum there, we need 2 there. So that would be our balanced equation. So we would need a 2 here, a 2 here, a 3 here, and a 3 here. So that's how we would do the first part of this. Now the second part your lab is asking you is which one of the 2 metals is more active. And if the equation moved forward, that means this aluminum donated electrons to this copper, so it's more active than the copper. So the aluminum is a more active metal than copper, right? And if we look down here at this equation where there's no reaction, that means that this reaction did not go forward. So in your lab, you'd write an NR here. That means that the hydrogen is more active than the copper. So if the reaction did not go forward, then you reverse that order of reaction there. Right, and so since we had a reaction here, we know that copper is more active than silver. And we had a reaction here, so we know aluminum is more active than hydrogen. And so for your lab, you'll go through and balance all of your equations, and then you'll have a table like this with which ones are more active than the other ones. Let's quickly do this one because people have trouble balancing this. What we have to remember is that hydrogen is going to be diatomic, so the aluminum is going to replace the hydrogen. Again, aluminum is going to be 3 plus, chlorine is going to be 1 minus. So to do our cross multiplying, we need 3 and 1. So one product is going to be AlCl3. And since hydrogen is diatomic, it's going to be H2. So remember that it has to be H2. If we go through, we would have to balance that equation, which these videos have to be short or we can't post them. So we're going to forego that. And now what you're trying to do with this data is make an activity series, which is a list from the most active metal to the least active metal. And so with the data we've collected here, we know that aluminum is more active than copper. We know that copper is more active than silver. We know that aluminum is more active than hydrogen. And we know that hydrogen is more active than copper, right? So what we want to do is look for whoever is the most active, and aluminum is more active than carbon or copper. Aluminum is more active than hydrogen. So if we start here and say aluminum is our most active, then we know that silver is probably going to be our least active. So now we're saying, well, is hydrogen or copper going to come next? And hydrogen from this experiment is more active than copper, so hydrogen would go here, then copper would come next, and then silver. So what you'll be doing is taking all the data we just generated earlier from mixing those chemicals. You'll be filling in your table, figuring out who's more active, less reactive, and then coming up with an activity series based on that.